this, the probability Bill wins the first game is 4/5. If he wins the first game, probably wins the second is 5/6. Blah, 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 blah. Okay. So we have to copy and complete the tree diagram. So obviously I'm not going to copy and complete it. I'm just going to do it on here. But please make sure that you don't write on the exam paper first at any of the section B's. Make sure you always write them on binding paper or the booklets you get given. So we know that if one probability would be 4/5, then the alternate must be 1/5 because we know they have to add up to 1. They've already filled in 5, 6, 1, 6. So let's just check out. So if Bill loses his first game, in other words, Andrea wins, the probability he wins the second game is 2/3. So this would be, oh gosh, 2/3, and Andrea would be 1/3. Okay. And find the probability that Bill wins the first game and Andrea wins the second. So if Bill wins the first game, we'd be following this branch, and Andrea wins the second game, we're following this branch. So if we want those two, it would be 4/5 multiplied by 1/6. I'm going to do some cross cancelling, so I've got 2 and 3, which gives me 2/15. Okay, the next one, find the probability that Bill wins at least one game. So, it's a different colour. So, Bill wins at least one game. So, we're talking about this situation here, and this situation here, because he won one, and then Andrea won, and also this situation here. So, Andrea won, and then Bill won. So, what we could do is find the probability of this event, and this event, and add them together. However, I'm a bit of a lazy person, so what I'm going to do is going to find that one situation that we're not interested in, and that's where Bill wins no games. And so I would do that by doing 1/5 multiplied by 1/3. And then I know that I want everything else, so therefore I would do 1 minus 1/15, which is 14/15. Okay, given that Bill wins at least one game, find the probability that he wins both games. Okay, so we have just found the probability that Bill wins at least one game. So we found this. That was 14/15. We need to find the probability he wins both games. So we would need to find that probability. So going back up to this diagram here, this is a win-win. So that's 4/5 multiplied by 5/6. Yeah, that's what it was. Again, I'm going to, do some cancelling. So that's 1 and 1. That's 2, 3, which gives me 2/3. Okay, we're now going to use the formula booklet. Snippet. Oh. So we'll snip this. This is conditional probability. Okay, so if I were to rearrange this, I'm trying to find the probability, the conditional probability situation here. So I know that the probability of B given A would be the probability of A and B, over the probability of A. So what we do now is we need to compare our events A and B. So in our case, the probability that Bill wins at least one game is event A, because it's given that. Okay, the probability he wins both games would be considered event B. Okay, So what we're going to do here is we're going to oops, hang on a minute. Oh, sorry about that. Okay, so we've got oh, I didn't mean to do. Okay, so we've got 2/3 on the top and then 14/15 on the bottom. So we're doing 2/3 divided by 14/15, which is 2/3 multiplied by 15/14. Simplifying that gives me 5/7. Should be done. Okay, so last question I think it is. To be honest, this isn't a nice one. Isn't, I said. Let's get going on this though. So the sides of a square are length 16. I'm showing that here. It's a square. Midpoints are joined to form a new square. Okay. Right, so the following table gives the values of xn and an. Copying complete again. Make sure that you do actually copy it. You don't just write it on here. So in diagram 1, which is obviously n1, x8, sorry, xn. So this is x1, and we can know that because this is the midpoint and when the original length is 16, that this side length must be 8. What's an area of the triangle? So we know to find the area of a triangle, it's 8 times 8 divided by 2, which gives us 32. Okay, next one. So we need to fill in this box here, which means that we need to know this length here. Now hopefully you can all see that that's the half of the hypotenuse of the triangle from this one here. So we know we're using Pythagoras' theorem. I'm just seeing if I can fit it in somewhere. Maybe we should do it here. So Pythagoras' theorem would be 8 squared plus 8 squared and square rooted. Okay. So that's 64 plus 64. So that's root 128. But it's half of that. So that's 128 root over, oh gosh, that's not very clear. Over 2. Right, this is a third situation, so we would want to try and simplify this at all. Basically, we want to try and get rid of that 2 on the bottom. So we say, does 4 go into 128? And luckily it does. So we're going to change this root 128 over 2 to root 4 root, oh gosh, so that's 32 over 2, and I remember root 4 is equal to 2, so they can cancel each other out. So that number there is root 32. And the area of that would be root 32 times root 32 divided by 2, which gives us 16. The next one, excuse me, is the, again, the half the hypotenuse. Oh gosh, space. So we're trying to find, oops, lost it, half of this length now. Okay, so we knew these bits were root 32. So it's going to be root 32 squared plus root 32 squared square rooted. Well, root 32 squared is obviously 32. Root 32 squared is obviously again 32. 32 plus 32 is 64. And the square root of 64 is 8. Okay. Okay. Part B. The process was repeated. Find A6. Okay, so what they're looking at here now is, rather than you carry on the pattern and carry on doing this, which you could, they ideally want you to look for a pattern for the a values. Hopefully you can see that this is divide by 2 and divide by 2 again. Remember, another way of saying dividing something by 2 would be multiplying it by half. So we would say that the fourth value would be 4, the fifth value would be 2, the sixth value would be 1. So we know that A6 is 1. Okay, so A6 equals 1. Almost there. Last one. Oops, a 7 marker. Okay, so consider the initial square of length k. The process described above is repeated indefinitely. The total area of shaded regions is k. Find the value of k. Alright, so the fact that they've used the word indefinitely here indicates that we're going to be using the sum of an infinite sequence, sum of a geometric sequence. So let's remind ourselves of the formula. So it's the sum of an infinite geometric sequence. So I cut half that off, sorry. Okay, and we can do this because we know it satisfies this criteria where the value of r is less than 1, because we just said that the value of r was 1/2. The value of u1 is 32. So we're going to say that the sum is going to be 32 over 1 minus a half. 32 divided by half. Same as before, 32 divided by 1/2 means that we're going to do 32 multiplied by 2 over 1, which gives us 64. Okay. Oh, Miss Harrison, what are you doing? One moment. That would teach me for not reading the question. Sorry, peeps. It is with a side length, initial side length of 1, so forget that. This is now k. We'll make mistakes. So we've got k over 1 minus a half. Oh no, what am I doing? We're talking about the area. Oh, good lord. Okay, hang on, let me stop this one and